One.
We're looking at differentiation, and of course we're going over the basic rules. This this video is going to be over the power rules. We're working our way right on down, and of course we found now ways to shortcut methods to finding these derivatives without having to use the definition, using that limit process to find the derivative. Okay, so this particular one here is the power rule. Let's look at the function m of x is equal to x to the third power. Now here's one that we haven't done. Okay, so what does the power rule state? Well, we'll write it generally here, but we're not going to do any proving, obviously. That's beyond the scope of this class. But what we're going to do is look at let's see if you can see the pattern. Patterns are pretty easy to see. We're trying to find these derivatives using, I call, the shortcut method. We don't want to use capital X. That would be something we'd use as a random variable in statistics. All right, the power rule. So we're going to take the derivative of this guy. Well, let's see if you can see the pattern. It's 3x squared. See a pattern? Let me work another one. What if we had y is equal to 7x squared? And we're asked to find y prime. So if you're asked to find y prime, that means you need to take the derivative. All right, see if you can see the pattern. 14x. Oh, just 14x. See a pattern yet? Do you see a pattern? All right, let's try this one. I was going to throw out all the different types of notation. D over dx. And this one will be, let's say, x to the 7th power. Can you imagine doing this using the definition of the derivative? That's that limit process. See if you can see a pattern. See a pattern yet? Well, if you don't see a pattern, let me help you. What we're doing here is we're taking whatever the power is up here and we're bringing it out front. It now becomes, it's the coefficient of x, and we're subtracting 1 from this power, so that gives us a 2. Pretty simple, right? So take the 2, bring it out front. 2 times 7 is 14, so now the coefficient of x becomes 14, and of course we subtract 1 from that 2. See that? Once again, we take this power, bring it out front. Now the coefficient is 7, and we subtract 1 from the power, which now becomes 6. I don't know, how simple is that, right? So more generally, you know what, I think I'll just copy this. We have x raised raised to the n power is equal to, so we take the n, bring it out front, right, rewriting the x, and raise that to the n minus 1. Now there needs to be quite a few things said here that we're not going to be getting into the details on this. And that is that n is a rational number. Okay, n's a rational number. So remember what rational numbers are. They're fractions, or they're fractions that can be reduced to integers, or we may say natural numbers, but a rational number, in other words, like a half, and maybe that's probably something we need to do. Maybe we should do that. Okay, but what I was going to say is that n is a rational number, and that the function f of x is equal to x to the n must be differentiable, and of course this is true here, right? There's some other things that need to be said about this, but we're going to leave it at that. But let's work. Let's go ahead and work one with a fraction up there in the power. Right. So we'll let n be, if you don't mind, I'll write it like this right here. How's that? Half is equal to, now we're going to bring the half out front. Okay, bring the half out front. X raised to, it's going to be, I'm going to put this in parentheses, half minus 1. Okay, see that? So when we go to reduce this thing down, and I guess it would be best that I wrote this thing as a fraction. And so we're going to end up with x on top, and of course the power, a half, what's a half minus 1? Right, half minus 1 is a negative a half. Give you a second, think about that. Whoops. And then what goes down here? Well, it'd just be a 2. See that? And of course we can rewrite this, putting that, not writing it with negative exponents, but writing it with positive exponents and taking that down into the bottom, which ends up becoming 1 over 2 times the square root of x. 2 times the square root of x. Okay, so that's the power rule. It's pretty simple. All right, pretty simple. We'll go over some more examples on this, because now we can put the power rule and the constant rule together as one. We're looking at the power rule that follows under differentiation. Let's look at this one here. Let's say we had r of x is equal to 1 over x raised to the third power, and we are asked to find r prime of x. And as you can see here, we're going to be using the power rule. First thing we're going to need to do, though, before we find r prime of x, is we're going to need to rewrite this to get it into a form so that we can take the power rule. So we need to rewrite this, and that means we're going to have to take this x cubed and take it up into the numerator, and that's going to end up making that x raised to the negative 3. See that? So our exponent is positive down here in the denominator, but when we raise it to the numerator, it becomes negative. Now it's in a form where we can take the derivative. And we shall do that. What do we do now? Remember, we take whatever's up here in the exponent, bring it out front, rewrite, and we subtract 1 from the exponent, so that makes that a negative 4. Okay, subtracting 1 from the exponent makes it a negative 4. Negative 3 minus 1 gives us negative 4, and most of the time we'll want to write this with positive exponents. And what that means is we'll have to take that back down into the denominator. So we're going to say negative. We'll bring the negative out front. Leaving the 3 in the numerator. X raised to the 4th power. X raised to the 4th power. Okay. All right, let's work another one here. Okay, we'll call this one, you know what, we'll just do this. Y is equal to, once again, we're going to do this where we have to rewrite it to get it into the form that we need, because this is going to be something that you're more than likely going to see. We'll say this one is X. Or did I already use 3? I already used 3. Heck, let's use 10. Let's use 10. Okay. And we're going to be asked to find y prime. So we want to find y prime. But the first thing we're going to need to do here is we're going to need to get this into a form so we can use the power rule. So we're going to rewrite it, and that's going to make that 7x. We're going to take this up into the numerator, and that becomes a negative 10. See that? That becomes a negative 10. It's a positive 10. Bring it up, and it becomes a negative 10. Be careful, they might try to trick you and make this a negative 10. This could be written as x to the negative 10th down here in the denominator, so when you bring it up, it becomes a positive 10, so be careful about that. All right. Now we can use the power rule, and that means that we're going to take the derivative. Let's go ahead and write y prime is equal to, so we take that negative 10, we bring it out front. I'm going to go ahead and put parentheses around our 7 here, okay, because it is multiplied. X raised, what do we do here? We subtract 1, so that becomes negative 11, right? Subtracting 1 becomes negative 11. And then we want to go ahead and clean this up. So we have negative 10 times 7. That gives us negative 70. Whoa. Negative 70. Right. Divided by x raised to the 11th power. Now you see this notation. Okay. We'll go ahead and write it. I'll just say equal to here. Negative, we'll write it, maybe you better understand it here. Put the 70 on top and the x to the 11th on the bottom. Okay, so there is our derivative. I think we have time to work another one here. Let's say, we'll call this one here G, for some rhyme or reason, is equal to, let's do another one here. Let's say negative 12 divided by x raised to the negative 12th. So you see something fishy? Right, so we need to rewrite this. We've got to rewrite it. So we're going to say G. So I'm kind of using a little bit different notation so you can see, get a feel for other types of ways of writing. I'm going to bring that negative out front. 12, we want to rewrite this. Yeah, I didn't need to do that. We want to rewrite this. So this x to the negative 12th is down in the denominator. We take it to the top, and it becomes x to the 12th power. All right, so this was that trick I was telling you about. Be careful about. Right. And now we're going to find that derivative. We're going to write g prime of x is equal to, taking that 12, bringing it out front. I'm going to go ahead and leave that negative there. And we have x raised to the negative negative 11. No, 11. So this is 12 minus 1. See, it almost tricked me. This is 12 minus 1, and 12 minus 1 is 11. So be careful about that. Okay. Is equal to negative 144 x raised to the 11th power. Okay. So we took this, took it up into the numerator. So we ended up with negative 12 times x to the 12th. Take the 12, bring it out front. 12 times 12. 12 times 12 is 144, I believe. And then subtracting 1 from the exponent gave us 11. Okay, I think we'll end that right there. And I think we'll work a little bit more complicated ones coming up. All right, let's look at some more examples. Let's say we have, we're going to go ahead and use this notation. D over dx. Now let's go ahead and combine the constant rule with the power rule, if you don't mind. We're going to do that, and you should try to work this out. Maybe pause the video and work this out. So what is this saying here? This is saying, hey, we need to take the derivative of this. And we're going to be taking the derivative of each one of these terms separately. Okay, and I think there's a theorem behind that, but all right, we'll talk about that here in a minute. But we're going to go through and take the derivative of each one of these separately. So what do we do here? We take the 2, we bring it out front. Whoops. Take the 2, bring it out front, subtract 1 from the exponent, plus, not this one here. Well, this one is, there's assumed to be a 1 up here in the exponent. We take the 1. Let me actually do some side work here on this one. I should have probably worked this one first. All right, so we take this 1, we bring it out front. And remember, we assume there's a 1 up there in the exponent. We subtract 1 from it. What do we end up with? 1x raised to the 0 power. So as you can see here, x to the 0 power is just 1. I'll go ahead and put parentheses around that. Whoa, what happened? So x to the 0 is 1, and 1 times 1 is just 1. So the derivative of x is 1. Now, what did we say the derivative of a constant is? The derivative of a constant is 0. Of course, we're not going to write that, right? We're not going to write that. Okay. So as you can see here, this derivative of x squared plus x plus 3 is 2x raised to the first power plus 1. But remember, we don't put a 1 right here. Okay, we just leave it off. So it's 2x plus 1. All right, let's work another one. And we'll go ahead and use this same notation. Same notation. This time we'll say 5x squared plus 4x plus 3. We want to find the derivative. So once again, we take the 2, we bring it out front. So 2 times 5, you know what? Let's not skip any steps here. We'll just write it out. What do we do here? We subtract 1 from the exponent, and that just becomes 1, but we're not going to write it. Plus, Now, once again, you take the 1, bring it out front. 1 times 4 is 4. And then, of course, remember, just like we did here, x, this would be x to the 0. See, so we'd just be left with 4. And the derivative of a constant is 0. But we're not going to leave it like that. It's 10x plus 4. 10x plus 4. All right. So this time we combined the power rule with the constant rule. See this? All right. I think in the next problem, what we're going to do is we're going to find the equation to the tangent line, and then we'll call it quits on the power rule. All right, using the power rule.
One.
Say we have y is equal to x cubed divided by 8. And what we're going to want to do here is we're going to want to find the equation to the tangent line at the point 2, 1. Let's take a look at the graph. All right, bringing up the graph, this is x cubed over 8. And we're at the point, what did I say, 2, 1, so right here. We're going to find the equation of the tangent line that passes through the point 2, 1. So we're going to be looking at a line, right? A line that's passing through this point. So you can see that the slope is going to be positive. So let's keep that in mind. Right? Passes through 2, 1. So the first thing we're going to need to do is find the derivative. Y prime is equal to, bringing the 3 out front, right? Subtracting 1 from the exponent, that gives us a 2, and we just go ahead and leave the 8 in the denominator, right? Leaving the 8 in the denominator. So if we're going to find the slope, here's the goal, remember. That's the goal. We want to find y is equal to mx plus b. Now let's keep in mind here that this y and this y are two different y's. Okay, these are, you could call this y of 1 if you want. Y sub 1, nah, it doesn't do it that way. We can call that y of 1 if you'd like. All right, y of 1 is equal to mx plus b. First thing we need to do is find m. Right, find m. And so m is simply going to be, m is equal to, so we're going to plug 2 in for our x, and that's going to give us, here we'll just write it out here, 2 raised to the, or what am I doing? Plugging 2 in. I think I better just bring up this equation here, box, so we get the proper notation written in. All right, m is equal to, so we're going to have 3, and then we're plugging 2 in for x, so this becomes 2 squared, and it's all over 8. Okay, now okay, so we're going to end up with, let's see, what do we got here for the slope? 2 squared is 4, and 4 goes into 8. I guess we're going to need to do this. All right, so 4, let's just write it out like this, or we're going to end up getting confused. Don't skip any steps. Start skipping steps, that's where mistakes were made. We can reduce this. 4 goes into 8 2 times, so this ends up with 3 over 2, or you could look at it as 1.5. The slope is 1.5. So there's our slope. Now we can use the slope-intercept form, or we could use the point-slope form for solving for B. I guess it's just all up to your own preference there on what you want to use. I'm going to go ahead and just use this one here. So this is our y1, okay, which happens to be 1 is equal to, our m is 3 over 2, and we'll go ahead and write it like this, 3 over 2. Our x is 2, right, plugging 2 in, that's right here, plug 2 in, and then of course we're trying to solve for b in this equation. As you can see here, nicely those 2's cancel out, so we end up with 1 is equal to, yeah, we'll write it down on the next line, probably be the best thing to do. 1 is equal to 3 plus b. So as you can see here, if we take this 3 to the other side, boy, that becomes annoying when that happens. Take the 3 to the, you know what, can we just get rid of that? Take the 3 to the other side, becomes 1 minus 3 is negative 2, so b becomes negative 2. All right, let's just write it out right here. So we have y is equal to, and I'd probably best if we do this. We said it was, we just called it y of 1, so we didn't get confused. Our m was 3 over 2. 3 over 2 x and minus 2. So 3 over 2 x minus 2. Now remember, if you take this 2 and you plug it in to here, you should get 1 out. Okay? Alright, if you don't, something's wrong. So 3 halves x minus 2. Let's go up here and graph this real quick. Not running out of time. Alright, so as you can see, that nicely graphs. So the x, this the graph of that's green here, you can see that is our tangent line at the point 2, 1. And as you can see, it crosses right here at negative 2. It's our y-intercept. So I think that's going to conclude. That's going to conclude our power rule, and we'll be getting into whatever the next rule I have on the list is.